Okay, yesterday we talked about changing slope and the effects on a situation by changing slopes. We also talked a little bit about direct variation. Just kind of a quick review. If you remember from yesterday, direct variation is y equals mx, or really the proper way to do it would be y equals kx, where here m is your slope, which is exactly the same thing, or equals your k, which is your constant of proportionality. Again, that's not something that we spend a lot of time on, but it is something that is good to know as you move forward. The biggest thing to remember and notice about the direct variation equations here is the fact that it always goes to the origin. Therefore, your y-intercept is always 0. If it has anything other than a 0 y-intercept, then it is not direct proportion, or not direct variation. All right, so today we're going to talk about changing b, or changing the y-intercept. We're going to get into that right now. All right. If you have proportional relationships, you have the following qualities. All right, so when we're talking about proportional relationships, again, we're talking about the slope being positive. I want to clarify one thing, is that when I say the slope is positive, it doesn't mean that it's always going to be positive. Primarily, your Algebra 1 class, you're going to see a lot of new things added to this as you continue up through, geometry, Algebra 2, and then on into college math. Okay, and then of course it does always pass to the origin. And again, another name for proportional relationships is direct variation, which we just talked about. Okay. All right, so let's go ahead and jump into a problem. It says Melinda is driving home at a speed of 80 kilometers. I guess we're in a foreign country. 80 kilometers per hour. Her distance from home is shown on the graph. So what is the y-intercept of this graph over here? Okay, we're looking at this graph on this side here. What's the y-intercept? Again, the y-intercept is where the graph crosses the y-axis, so you're going to see that right there at 400. Remember, it's key that you understand that that's the y-intercept. That's the y-axis, and that's the x-axis. Okay, so the y-intercept then is b equals 400. And make sure you put that together. And again, if you put that in order pair form, you have a 0 for the x and then 400 up on the y. Okay, so what would happen if to the graph if the y-intercept were increased by 40? Okay, so what would happen if you increased by 40? Well, increase, okay, the word increase right there is a key word to tell you to go up. So you're going to move the graph up by 40. Basically, you would just take 40 plus the original 400, that's the y-intercept, and then your new y-intercept would be 440. So that'd be your new y-intercept. What would happen to the graph now? Okay, because that's the key. Well, if I take this b equals 440 and I plot this over here in just kind of a general range, you see that your graph is being shifted up 40 units, right? So not only is it shifted up, but it's up 40 kilometers in this case. Okay? So to answer this question directly, the graph would be shifted up 40 kilometers. All right, C says, what would this increase of 40 mean in our situation? Well, what does the y-intercept mean initially? Initially, the y-intercept means, again, if you remember what we talked about when we first introduced this, the y-intercept was the initial value the beginning points, the constant rates. It's like where you start from. So in this situation, initially with the y-intercept being 400, Melinda was 400 kilometers from her house. So if I shifted it up 400 or shifted up 40 kilometers or to 440, now instead of starting 400 kilometers from her house, she's a little bit further back at 440 kilometers from her house. Okay, so she's 440 kilometers from home. As opposed again to the 400. Okay, let's look at our next question. If the y-intercept were halved, what would the new y-intercept be? Again, we take our original y-intercept, we cut it in half. Well, our original y-intercept is 400. So if we cut it in half, b would equal 400 divided by 2. Or we have to always reduce. b equals 200. Okay, and again, ordered pair form, 0, 200. It's good practice to put it in ordered pair form so you know how to see it both ways when it comes up. Okay, in this case, what would be the effect on the graph? Okay, now this time I'm not going to go back to the graph and show you. I want you to use your common sense to logically reason your answer. Well, 440 increased the graph. We went up 40 units. We increased it. Here we're halving. Okay, we're cutting in half. So in that case, that's another keyword for decreasing, right? So we're decreasing it by half. Well, what's half of 400? That's 200. So we're going down 200 kilometers. So the graph would be shifted down 200 kilometers. Okay, and that's of course down the y-axis. Now, just like the 400 or the 440, what does this mean for our situation, or what does this mean for Melinda? Well, for Melinda, this means that she's actually closer to home. So she's closer to home compared to the original scenario. So this time she's only 200 kilometers from home. Okay? Now if Ronnie drives home at the same rate as Melinda, but he lives 300 kilometers away, describe how the graph has changed. Okay? Using the same scenario. Alright, so Ronnie's driving home at the same rate as Melinda, but he lives 300 kilometers. So if he's driving home at the same rate, that's a key word that I don't want to overlook here. So he drives home at the same rate. What does that mean? Okay, this is just kind of off the topic just a little bit, but it's good for you to know. What does this mean? Yeah, that means they have the same slope. Okay, so they have the same slope. Now, let's go ahead and get back to our question. So he drives home, but he now lives 300 kilometers. But he lives 300 kilometers. Well, first of all, in a scenario-based, he lives closer. And again, this is going back to that 400, okay? It's going back to that 400 kilometer scenario. So he lives closer, but the graph, okay, how is the graph affected? The graph says is going to be shifted down 100 units, 100 kilometers. Think about that. We're going from 400 to 300, so that's a decrease of 100, so that's where you're getting that down shift of 100 kilometers. Okay? Does this graph represent a proportional relationship? And give evidence to support your answer. Okay? Well, remember, what is a proportional relationship? A proportional relationship is direct variation, right? So basically this question is asking you, is this direct variation? Okay, when it's asking this right here is basically saying, is this direct variation? Okay, so again, like I said, this question is really asking, is this a direct variation? And then give evidence if so. Okay, so if we look at our graph, excuse me, if we look at our graph back at the beginning, let me go back a little bit. If we look at our initial graph here in this red box, one of the things that we can do, the quick, easy indicator of if it's a direct variation, is by checking to see if it goes to the origin. So that tells us if it's a proportional relationship. So let's take a look. Okay, is this direct variation? Does our graph go to the origin? Again, for those of you who are unfamiliar with this, you shouldn't be, but those of you who are, the origin is right here. Okay, so does the graph go to the origin? It does not, therefore it is not a direct variation equation, or it's not proportional. Okay, so the answer would be no, does not go through the origin. Okay? All right, let's look at our next example. Again, we're going to start dealing with our parent linear function. We did this on last night's video as well. Again, just knowing these parent linear functions, parent quadratic functions, and stuff like that, that's going to make all of your math life a lot more simpler. So let's go ahead and jump right into this. Again, what's the parent linear function? That's right, it's y equals x. Hopefully by now you have that memorized. Just like yesterday, if x is negative 2, y is negative 2. If x is negative 1, y is negative 1, 0, and basically it's just shadowing the same number. Okay, again, like yesterday, let's enlarge this graph a little bit. This graph's not the best graph, but it's going to go through your origin, and it's basically going to go up 1 over 1. And again, this isn't perfect, but it's pretty close. Okay, so here's your graph of the parent linear function. Again, don't forget those arrows. Okay. All right. So now let's go ahead and take a look at some of these questions. When you change the y-intercept or the b, it changes the starting value of the function, so it changes the initial value. A lot of times, the reason why, just to go back one step, the reason why we're talking about the parent linear function, because a lot of times you'll have STAR or EOC questions that ask you specifically about changing the parent function and how it is changed in the graph. So that's why we're going to touch this on each one of these topics. Okay. So now it's asking you, when you change the y-intercept or the b, it changes the starting value of the function. How would the graph of y equals 4x minus 1 change if the y-intercept was changed to negative 5? Okay, so again, looking at this graph or this function or equation right there, what is our y-intercept? Okay, and for those of you guys who are still struggling with this, remember, just put y equals mx plus b over it. And where's the b value? Okay, that's right, the b value is right there, that negative 1. So our initial b value is negative 1, so b equals negative 1. Okay, and it is going to transform into b equals negative 5. Just for a little extra practice, what would the new equation be? What would the new function be? Yeah, it would be y equals 4x minus 5. So I did not change the slope at all. I just changed the y-intercept. Okay, so how would the graph change? Okay, the graph would change because if I'm going negative 5, I'm going from negative 1. Okay, negative 5 is which direction? Okay, again, thinking about the y-intercept, so the y-axis, so negative 5 is going to go down, not left or right, but down to get to negative 5. How many units did I have to go? I had to go down 4 units. So you would say the graph shifted 4 units down. So the graph shifted 4 units down from going from negative 1 to a negative 5. Did the magnitude of the graph change at all? No, it did not. The magnitude stayed the same because we did not do anything with the slope. So the graph is still going to be tilted or slanted exactly the same as it was. The graph is just going to be shifted straight up or down. In this case, it's down 4 units. Okay, let's look at number 3. What is the effect on the graph of y equals negative 2x minus 3 if the new equation is y equals negative 2x plus 1? All right, so let's compare. Did the slope change? Well, here's the slope right here. So that's a negative 2. And over here, here's the slope. That's negative 2. Nope, slope didn't change. Okay, so our magnitude is not changing. So the angle at which our graph is drawn is not changing. So negative 3. Did negative 3 change? Yep, negative 3 went from positive 1 to positive 1. So negative 3 represents our b. So b is negative 3. It changed to a positive 1. Okay, again, if I have negative 3, where is the 1 on our y-axis? That's right, it's up. So we have to go up to 1, right? Okay, well, how many units do we have to go up to get to 1? Well, we went from negative 3 to negative 2, that's 1 unit. Negative 2 to negative 1, that's 2 units. Negative 1 to 0, that's 3 units. And then we went from 0 to 1, that's 4 units. So we actually shifted up 4 this time. So you would write the graph shifted 4 units up. Now be careful with this because I just want you to understand that you can have 2 negative numbers and it still shift up. So I don't want to say just because it's negative, it's always going to be an up or down unit. Because here in this case, we went from a negative to a positive, so that shifted up. But what if I shifted from negative 5 to a negative 1? Well, negative 5, I've come over here on the side, is down here, and negative 1 on the y-axis is up here. So that's still a positive shift. That's a shift upward of 4 units. So just because you have a negative number doesn't mean it's always just going to be a negative shift or a downshift. Okay, so you have to make sure you pay attention to the spots on the y-axis and then move up and down accordingly. Okay. And again, if you have any questions, please let me know. All right, let's look at our last example. Whoops. All right, our last example up here, number 4. It says, given y equals x minus 4, what is the new equation if the y-intercept is decreased by 4? So this key word, decreased, tells us that we are going to go down. Okay, a shift downward is going to be a negative, correct? A minus, right? So we're going to subtract 4. Okay. So what is the new equation if the y-intercept has been decreased by 4? So we're going to take the original equation, original equation, and tell me what the y-intercept is right now. Well, if you look here, it's this right here, negative 4. Don't forget the negative part. So the original equation is negative 4. So you got b equals negative 4, and you're going to shift it down. So we said we're going to subtract 4. Because shifting it down or decreasing it by 4, we're going to subtract 4. So then you end up with negative 4 minus 4 equals negative 8. Please use your calculators if you need to. So now you have a new y-intercept of b equals negative 8. So then if I rewrite the equation, did I change the slope at all? No. So to rewrite the equation, I have y equals, keep the same slope, which is 1, or x, minus 8. And that's how I'd rewrite the equation. Pretty simple. So again, just like yesterday, just a quick summary. The graph can be shifted up if your b is bigger. So if your b is larger, okay, not absolute value here. We're not talking about absolute value like we did with the slope. If your b is actually bigger, okay, so -1 is bigger than -5. If it's bigger, your graph's going to go upward. If your b is smaller, your graph's going to go downward. If you increase, you shift your graph up. If you decrease, you shift your graph down. Okay, and I'd actually probably write that in the summary as well. I'm going to write that down here. Not with that. So increase, up. And again, a lot of this is common sense, but it's good to have a safety net of notes, right? Increase up, decrease, down. And that's it. I'm glad, hopefully you watched this video, you got something out of it, and tomorrow you come to class and do your work again. And just keep working hard. If you have any questions, come see me in tutoring. Again, I told you guys today about PASS. Always feel free to come see me in PASS. If you have any questions, please don't be afraid to ask. It's your last 6 weeks before the semester ends. You want to make sure you pass so you can get your credits. All right, you guys have a good night.